Okay guys, tonight I'm going to work on some of your homework that was just assigned to you today from Mr. Lee, and you should recognize this worksheet. This is the free fall worksheet, and it starts off: a tourist drops a rock from rest from a guardrail overlooking a valley. Find its displacement at t equals 4 seconds. Find the time it takes to reach a speed of 35 meters per second. The time for it to reach a velocity of negative 35 meters per second, the time required for it to fall 400 meters, its speed after falling 80 meters. Now, one thing I really want to stress, guys, this text is in red because it's different than yours. I wanted to solve for a unique situation and not give you the direct answers, and just basically show you how to do this. So I'm going to give myself a little bit more space, scroll down a little bit, and here we go. So let us do A. Now A. Well, A says we're going to find its displacement, and that's going to be our dy is our unknown. Okay, start off that with our dy. Always like to put this, the dy equals a question mark, and it's always good to note what's our unknown. Its displacement for time equals 4 seconds. Okay, so, oh my goodness, Mr. Shaw, this is all it gives us. It only gives us two things. Well, guys, remember, it says up here that he drops it from rest. So if you drop it from rest, that means your Vyi is 0. The next thing I want to stress, guys, is that what force is going to pull this rock, this object, downward? Well, that's going to be the acceleration due to gravity. So our AY, our acceleration in the y direction, is in fact the acceleration due to gravity, and it's going to be negative 9.81 meters per second squared. Okay, so we can list some formulas that we can choose from. Let's pick another color. We've got a whole slew of formulas I've given to you in class. That includes VYF equals VYI plus AYT. I've given you dy equals VYI t plus 1/2 AYT squared. And I've also given you VYF squared equals VYI squared plus 2 AY dy. Now, guys, these are just the formulas found in your reference table, except I've made them more specific by saying we're going to be in the y-axis, so I've added these y's here. Okay, don't be too afraid, guys. These should be familiar to you by now. The y's just tell you the direction, the axes. Okay, so we're going to look for which one of them has our variables. So you see we have dy, so this one and this one has dy. It has VI. Let's go down here. We're going to skip one. Both these have VI. Okay. This one has VI, but it doesn't matter. It's already been removed, so because it doesn't have D. A. Well, they both have A. So then let's take a look at the deal breaker, time. Which one has time? This one has time. This one does not. So right now we've decided that this is the formula we have to go with. I'm going to undo this. So this is the formula right here we're going to go with because it has time. So we just plug in. You're going to say dy equals, let me pick a different color, let's go to like a dark blue. Dy equals your VYI, which is 0 meters per second, multiplied by your time of 4 seconds. And you'll realize that Mr. Shaw just loves parentheses. 1/2 times negative 9.81 meters per second squared, times your time, which is 4 seconds quantity squared. Now, you'll notice this term cancels out. You get a much simpler looking thing. Dy equals negative 4.905 meters. That's just 1/2 times this per second squared. Times what's 4 squared? That's going to give us a 16 seconds squared. Okay, so I'm just I have a calculator next to me. I'm going to plug that in. I have negative 4.905 times 16, and that's going to give me a value equal to negative 78.48 Now what's the value, guys? Well, you take a look at this. You have meters per second squared times seconds squared over 1. These cancel out, and you're left with simply meters. So that is your answer to part A. Okay, let's clear this off. This is your answer to A. This is how you do it. You do these formulas. All right, let's clear this off. I want to leave my formulas up there, so I'm just going to try and get my eraser out. Where's my eraser? I think this is it. Isn't there a bigger eraser? The land of small eraser tools. Okay. So now, let's move on to part B. B is the time. I guess I could do something different. Let's do this. That's much better. Okay. Find the time for it to reach a speed of 35 meters per second. Now, this one, guys, the key point right here is this word right here, speed. Now, Mr. Lee went over this today. What is speed? Well, speed is a scalar. It doesn't have a direction. So speed is a scalar, meaning it doesn't have direction. So basically, the great formula that Mr. Lee gave you, and I never even thought of just saying it so eloquently, is the absolute value of velocity. So if you have a velocity of 35 meters per second south, it's going to be, the speed is just going to be 35 meters. You're not meters per second. You're not going to have to give a direction with it. Okay, so speed is a scalar, and you have this formula for it. So our speed is 35 meters per second equals the absolute velocity, value of velocity. So that means velocity could equal plus or minus 35 meters per second. Okay, well, is it positive? Is it negative? Well, when you drop an object, which way does it go? So your velocity in this part is going to be negative 35 meters per second. And that's because when you drop an object, where does it go? It goes down. Now, the next thing you need to realize, guys, is this your initial velocity or your final velocity? Well, you've already given us in the problem that it starts at rest. So this is in fact going to be your, don't move it, VYF is what this is going to be. Okay. So you have your VYF. You know, once again, let's get rid of all this. Well, let's get rid of this. You should know that you have an initial velocity equal to 0, because it's the same situation. You know your acceleration, again, is going to be gravity pulling this down. Okay, and the next thing it's saying is the time. So you're looking for time. I'm going to put that at the very top, because that's where I have room, question mark. And looking up here for formulas, well, you know it can't be this one, because this formula doesn't have time. You need something that doesn't have displacement, because we don't have displacement here. So we only have one option. That's the very first formula. So you're going to get VYF. Let me just do this. You're going to get VYF, which is negative 35 meters per second, equals VYI, 0 meters per second, plus AY, which is negative 9.81 meters per second squared, times time. So divide both sides. Now you see you got a nice little formula. You can simplify this. I don't want to get ahead of myself. Times time. So now you want to divide both sides by your by this acceleration here, and when you do that, divide both sides by negative 9.81 meters per second squared divided by negative 9.81 meters per second squared. This cancels out, and you're left with negative 35. I'm doing it on my calculator again. Negative 35 divided by negative 9.81. Negatives cancel out, and you'll get a time equal to 3.568 seconds. Okay, that's going to conclude our first portion. I'm going to do C, D, and E when we get back. Okay.